For years, our industry has used the same methods to gather and preserve data: paper and electronic versions of paper. But as our facilities age, so do our records. For us, the underground is the challenge. You can't see it. It's dark. It's buried. It's hazardous. Half of our engineering time was spent on research, and half our research time was spent on field verification. It's a problem common to utilities, and it can feel a little like utility anthropology. Records can misconstrue, line types may become ambiguous, and incomplete data is as bad as bad data. What if there was a better way to show what we had? At AU 2013, we discovered it. By harnessing the power of recap software, we were able to create 3D models. We instantly saw unlimited possibilities. We could use this technology to model our substations, vaults, pole assemblies, trenches, underground ducts, transformers, switch cabinets, junction boxes. Although we've done this dozens of times, we're always improving our methods and techniques. There are many obstacles to modeling these underground vaults. It is not a casual endeavor. This includes blocking off traffic to access our manholes and roads, scheduling 3 to 6 men from our operations department, sometimes deploying a vacuum truck to remove water if the vaults are full. We are continually monitoring the atmospheric conditions inside the vault. Some of these vaults are large enough to fit a truck, others are the size of a large hot tub. Add a couple of switches, a transformer or two, and coils of high voltage cables, and these become dangerous and cramped places to work for one man, let alone two. We employ high capacity lights for our cameras, as this produces the best models. Due to the nature of our equipment, we don't know if we have a successful model until after we've run the pictures through recap, so sometimes we must repeat this procedure. We model these because we are anticipating unknown needs of a cross-multitude of disciplines. Paper just can't do that. We select about half of our pictures to upload them into the recap software. This is a model viewed in Recap 360 on the PC. It is a stunning portrayal inside one of our vaults with a switch cabinet on top. Where before we had a butterfly diagram showing the cable routes, now we can see the actual entrance and exit conduits from the vault. We can take measurements from any 2 points. We can virtually put any of our personnel inside this vault safely now. This is a vault in Memento on PC. You can see that it is rendered as a whole, including the outside walls. This vault is particularly cramped. It was very hard to get our lights in here and get a good data capture. In this model, as many of our models, detail is clear enough to read tags on our cables. You can see the detail of our switch and see its positions. Here is a wireframe of the same vault. And here's the vault in solid. This is a great example of the value these models provide. This is a complex intersection where we came in with a dozen conduits and maneuvered around gas, cable, TV, fiber optics, water, and sewer in a particularly crowded alleyway. This area is now covered in concrete and will never be opened up again. This vault is also in the iOS. This is the same quality that our field hands will receive. Notice the dark spot on the wall. That's where the water level was before we emptied this vault. Why do we do this? Why would we go to such great lengths to gather this data? At the utility level, it's about gathering and preserving data for the future. Many times it's difficult, sometimes impossible to go back. Different disciplines have different needs we cannot yet anticipate. By creating these models, we can avoid costly field visits. We can share and collaborate over time and space at almost no cost. A line type may be misrepresented, but a 3D model is clear and certain. Lastly, we'd like to show you the direction in which we're moving. In the future, we plan on uploading these models and having all of our plant modeled in 3D into the InfoWorks software package. This is a rough draft of what we think it will look like. Thank you for watching our presentation.